In this video, we'll take up the homework on the factor form practice. So the first question is asking us, how do you find the vertex if it's given to us in factored form? So determine the zeros, average the zeros, find the y-coordinate of the vertex, and then using AH and K, you can write it in vertex form. For a second question, find the zeros. So luckily, all of them are factorable. So the first two are simple trinomials, and the third one's a complex trinomial. But nonetheless, just factoring, you'll be able to extract the zeros from the factors. For the third question, you want to take the zeros from the second questions. Find the vertex of the quadratic functions in the second question. Average the zeros, and then you can find the x-coordinate of the vertex, and then solve for the y-coordinate of the vertex. Question 4 and 5 are very similar. You're given the zeros and a point. So using the zeros, you can create the factors, and then you can use the points to solve for the a value, and then you're done. Let's see. For question 6, question 6 is very similar to 4 and 5. So I actually wrote an extra step for question 6 afterwards, because a lot of students, I want to show a lot of students how I came about the second line. So remember, factored form is x minus r times x minus s. In this case, r and s are 0. Well, they're always zeros, but in this case, the zeros are irrational. So -2 plus root 3, and then -2 minus root 3. So apply the distributive property, and you'll get the second line. So you have to multiply trinomial by trinomial. And you can do it using distributive property, but the shortcut is to visualize the difference of squares, okay? Or visualize that these factors are conjugates. A minus b times a plus b, where a is x plus 2 and b is root 3. So you get a squared minus b squared. If you don't like the shortcut, then just do it the long way. You'll still get the same answer. For question 7, I have it in vertex form, and they want me to express the zeros. So I just rearranged it. But if you chose not to rearrange it, you can expand it and put it in standard form, and then factor, and you'll get the same answers. For question 8, luckily the 2 points they gave me have the same y-coordinate, which means I can use the idea of symmetry to solve for the axis of symmetry, and then I have the vertex, and you can solve for the equation. Question 9 is silly. 3, 8 can't possibly be the vertex because it's neither the maximum, or it's not the highest or lowest point. It's not the maximum or the minimum point, so yeah, not possible. For question 10, basically what they gave us tells us the vertex. And yeah, with the vertex, I can tell you an infinite number of quadratic functions. Okay, so yeah, I need to know a specific point in order to solve for the value of a. Otherwise, I have an infinite number of quadratic functions that can satisfy the given conditions at the moment. For number 11, no, I can't have 3 zeros. So what I wrote is really nice. How can you have 3 zeros from 2 linear factors? Just not possible. Okay, last question. Basically, let y equal 18, and then set equal to 0, factor, and there's your answer. So x is either 4 or -3. And those values of x will get you a y value of 18. Okay, so as long as you know how to factor, then you're able to solve these equations very quickly. But if you don't, then hopefully remember the quadratic formula.